So today we're going to talk about domains and ranges of functions. First of all, do you remember a simple little test you could do on a graph to see whether or not that graph was a function or not? Something test. Vertical line test. Very good. And the vertical line test goes like this. You take a vertical line. I'm going to make a nice bright fuchsia vertical line here. And then that vertical line, if I move it through this and it never touches twice, if it only touches once at a time, then that passes the vertical line test. So is this black thing a function or not? Yes, it is. And all it would take to not be a function would be to, for instance, have some kind of like a little, like some place where it comes back on itself like that. Even though it looks neato, you can't have that because then it would touch 3 times, in fact, in that case. And that means one input, like the input of 8. If I stick in an 8 into the function, it will give me 3 different answers. One for this, and one for that. So it hits 3 times. So one input's supposed to have one output. Okay? But if you got more than one output, then it's not going to be a function. All right, so the very beginning of this is really easy. Is it a function or not? And all you'll have to do is tell me whether or not it passes the vertical line test. All right, so that part's easy. Next part is domain and range of a function. All right, you're going to need to remember a few functions that you learned last year. Do you remember what that one looks like? Sketch it quick. Write it out, sketch it. You're going to have to be able to say the domain and range of every function you ever meet. And if you have a picture for it, it's really pretty easy. So if I want the domain and range of y equals x squared, here's y equals x squared, basically. The domain you can tell by seeing how far does it go this way, and then how far does it go that way. Will it go forever in both directions without issues? And this one will keep going forever in both directions. So its domain would be from negative infinity to positive infinity. So that's a function you're used to. You're used to seeing that way. You know it's a function, passes the vertical line test. How about the range of it? The range of it, does it go forever? Remember, like the other one was left and right. This is up and down. Always start with how low to how high, because your low number has to be first. So how low does this go? Well, there is a limit. It doesn't just go to negative infinity. 0. It goes from 0 to, and how high does it go? Infinity. Now, infinities always have parentheses around them, so we haven't had to think about that till now. But that 0, does it actually touch 0, or does it just get really close and never actually touches it? It touches 0. So therefore, it's a bracket there. Okay, so there's the basic idea of domain and range. Domain is the x's, and it's left-right. Range is the y's, and it's up-down. Except I would think of it as down and then up, because you want to always start with the low number. It's really common for kids to get these goofed up and write it this way. And they think it means the same thing, but you can't do that. It's like saying something backwards. Saying you love instead of love you makes a big difference. All right, so let's say that we had a different function. Let's say we had, you've seen this one before, square root function. It keeps going up. Don't let that fool you. It looks like it's leveled off there, but it's going to keep going up, 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 up. In fact, maybe I should even make it more obvious that it keeps going up, up, up. All right, so then tell me, what's the domain and range of this function right here? This isn't the normal square root. It's actually been shifted 1 to the left. So this would actually be the square root of x, except it's been moved 1 to the left. Remember how to do that? Plus 1. Good. Okay. Okay, so what's the domain and range of that? Give it a shot, and I'll tell you in a second if you're right. Okay, I'm back. Domain, left to right. How far left does this thing go? -1. To how far to the right will it go? Infinity. Does it actually touch at -1? So it's a bracket. Curve on infinity. Parenthesis. All right, range. How low does it go to how high? Remember, always start with how low first. What's the lowest it goes? 0. This is an up-down thing, not a left-right thing. So how low? The lowest it goes is right there. It stops at 0. all the way to infinity, and it does touch at 0, so there we go. See, I didn't have any negative infinities on this thing? Why didn't I have any negative numbers on this thing? Yep, now I'll go to the right, okay, or up. But how about, why doesn't this function ever go to the left? Because, yeah, you'd have negative numbers. And can you have negative numbers underneath the square root? No. That's why it doesn't work. Okay, now that's getting domain and range from pictures. And, in fact, when you do range, that's the only way you can do it. Okay, so if I asked you for the range and I gave you a function, what's the range of y equals x squared plus 3? You'd have to be able to graph it in your head or sketch it and then figure out the range from that. There's no other mathematical way that we're teaching you anyway. Okay, so can you just make a quick sketch of that and tell me what the range is? That's a typical test question. It's an easy one. It's like an R2, but what's the range of y equals x squared plus 3? So if it's a function, x squared, and it's been shifted up 3, so it kind of looks like that, right? So then what's the range of it? What's the lowest it goes? 3. To highest it goes? Infinity. Bracket on the 3 because it would touch at 3. Never gets to infinity. 3 to infinity. Raise your hand if you had that one right. Okay, good. Then, this is harder though. What's the domain of something like this? 1 over x plus 4. These you do not want to try to draw a picture for. Yes, it's true, it does kind of look like this, if you remember that function, but I wouldn't try to draw the picture for it. There's a mathematical way to do the domain. And the domain is really asking, what number would mess this up? Like, on the actual graph of it, the graph would look like this, and it would, if I moved this thing, I'd be moving it which way, left or right? The plus 4 there to remind you, left 4. So I go left 4. But I wouldn't try to do this from the picture, but I want you to see in the picture what makes the problem. Do you get that I can go forever this way on this function? It goes forever to the left, and it goes forever to the right. But what's the problem? There's one spot in the middle that it can't exist. And that spot is at negative 4. Right here. That function can never exist right there. So what we have there is called, did you remember what that's called? It starts with an A. No, that's an asymptote. It's got an asymptote there. And if you, now I'm seeing it in the picture, and I'm seeing that negative 4 is where the problem would be. And everywhere else it can exist except that one spot. It tries to avoid it. It's like if it was coming from this way, it goes up and it's like, oh, I don't want to touch the green line. Same thing if it was going down like this. It can't touch that green line. Why? Because if it touched that green line, it would be having a negative 4 right here. And do you get why that's a problem? Because you'd have 1 over what? 0. And if you'd ever tried 1 over 0 on a calculator, you might have noticed it says error. It can't handle that. So what you're looking for on a domain is what are all the things that work? And so by really, you don't want to try to list everything that works. You want to think of what are the things that don't work. All right, so here's another one. 1 over x plus 2, x minus 3. Anything would work in this function except what? Because all the numbers work in the world except 2 things. Yep, negative 2 would be a problem, and positive 3 would be a problem. Because if it was either one of those 2 numbers, then the denominator would become a 0. So all real numbers would work in this, except the x cannot be negative 2, and x cannot be 3. Do you get what I'm saying? If I put in a 3 here, do you get how the whole thing crashes? You don't have to have a 2 and a 3 at the same time, just a 3. Put in a 3, and then I put a 3 here also. So what if this is 5? This part here is becoming up to be 3 minus 3 makes 0, and 0 times 5 would make it 0. So if I put in a 3 in, the whole function crashes. All right, so it creates an asymptote at 3. We don't have to worry about that till later. For today, all we have to know is what are the things that would make this function crash. And if this function works everywhere except negative 2 and 3, this is one way to write it. Another way to write it would be that it works from negative infinity until you get to what? Nope. Negative, I think negative 2. Is that what you said, or did you say negative 3? Anyway, it works until you get to negative 2. And then does it actually work at negative 2? So we put a curve around that. See what I'm saying? It works everywhere between negative infinity and negative 2. And then it starts working again at 3, except not actually at 3, but between 3 and infinity. I probably should have drawn the number line in between there, because some of you, I think maybe this is trying to go too fast. Come on. So I'm going to, okay. I'm going to write the number line in between. Maybe it'll make you understand it better. Do you get how everything works except negative 2 and 3? So these don't work, but everything else does. And do you see how the number line actually showed me another area I didn't write down? What's the other area that I didn't list? Do you get how it's working between negative 2 and 3? Okay, so there's 3 parts where it works. That, and that. Okay, I want to give you another one. Let's say we had 1 over x plus 4, and I'll put an x in front of it. That little x in front of it sometimes messes with people's heads. It's really not supposed to be that scary, but there are 2 answers. The obvious one is negative 4. What's the other thing? 0. Think of it this way. If I took this and set it equal to 0, isn't that just like the problems we just did last month or week? We'd have 2 answers, right? X equals 0 and x equals negative 4. Like that? Those are the 2 key spots. So I personally would recommend you make a number line. And you say, okay, here's my 2 key spots, 0 and negative 4. And those are the 2 things that don't work. Put an empty spot. Those are extraneous. Those are asymptotes. I'm going to put a little a above them for asymptotes. And then everything else works. Because unless it crashes the denominator, it's okay. It works.
We don't have to do anything like plugging in like a random number.
Nope. Don't have to test points. Nope. Can if you want. I mean, if you really want to try it, like prove it to you, to prove that 2 works, I'll stick in a 2. Put a 2 in, put a 2 in. You see how it doesn't crash? That's all we care about, is it doesn't crash. I don't care what it equals. Comes out to some decimal. Don't care what it is even. All I care is that it doesn't end up being something divided by 0. Can't have a 0 down here. That's all you're really watching out for. Why is the 0 what? Okay. All right, so my final answer would not be this part. That was just help to make my number line. My final answer would be that it works from negative infinity until you hit 0, and it doesn't work anymore. Union with works again from 0 to negative 4, and then union with negative 4 to infinity. That's its domain. Okay, I must be doing something wrong here.
Negative 4 is
I have my numbers backwards, yes. Okay, it's still going to be the, yeah. I wrote it backwards. Let's get it straight here. I was wondering why I was getting so many puzzled looks. Negative 4 should have been first, and then 0. All right, that's an empty spot. That's an empty spot. Those are the 2 things that cause it to crash, is if x equals 0 and x equals negative 4. I'm going to get this junk out of here. It was just me proving that 2 would have worked. Okay, so now, where does it work? It works from negative infinity up until it hits negative 4. Union with, it works again in here between negative 4 and 0. And then it works again from 0 to infinity. That's its domain. Now, I'm okay with you writing it the other way, where you say all real numbers except, you know this big R? Did you know that that means all real numbers? If you didn't, then you just learned something. That stands for all real numbers. You make it by making a double line and then making it look like an R. Okay? All real numbers except x cannot be -4 and x cannot be 0. That's another way to write the same thing. All right, there's one more thing that can mess up an equation that is, and it's not just that the denominator is 0, it's if you have a square root in your problem. Do you remember me doing this one just a minute ago? Do you remember how all the negatives numbers would mess it up? Okay, so we got to figure out where would this thing stay greater than 0, because if it or equal to 0, even 0 is okay. The square root of 0 is totally okay. Square root of 0 is 0. It's an okay thing. It's as soon as you get a negative number that you have a problem. So you should say that x plus 4 needs to be greater than or equal to 0 and solve that little problem. Subtract 4. X has to be greater than or equal to -4. Can I put that on a number line? Yeah, I can do that. Here's -4. X has to be bigger than or equal to it. That means it can be, notice that or equal to sign filled in. And greater than or equal to looks like this. So that means that its domain is numbers like -4 or 0 or 25 or any number that's bigger than -4. So final answer, -4 to infinity. Can it be -4? Yes, bracket. There we go. That is the domain of that function. All right, so there's two kinds you have to watch out for. One is where the denominator's got issues. And the other is where you got a square root. I want you to tell me quick what you think the number line would look like for the domain for the blue one and the red one. Try them right now. The number line, you don't have to go through and make the whole brackets, parentheses, commas, unions. Just make me a number line for both of them. Domain for this, domain for this. Just think about it. What's inside the black circle there? Do you ever want that to be negative? So you want it to be 0 or bigger, right? So you want to set x minus 17 to be greater than or equal to 0. Then you add 17 to both sides. You want x to be greater than or equal to 0. No, 17. Sorry, add 17. There we go. And then a number line for it. Here's 17. And it's supposed to be equal to that or bigger than that. So there we go. Raise your hand if you had that one right. Okay, good. The other one, the blue one. Everything works except -3 and 5. So you'd make a number line. Here's -3. Here's 5. Can't be this, can't be that, but it can be everything else. If I was going to write it with the parentheses and everything, I'd say negative infinity to -3. I did not need you to do this, but in case you wanted to know. Union with -3 to 5. Union with 5 to infinity. All right, and the hardest kind of all, which would kind of be moving it up to like the R3 level, would be what if they throw in a square root on top and on the bottom they had that. Remember, I wouldn't ever ask you the range of this because on the range ones, there'll be kinds you can draw a picture for. I have no clue what the picture would look like for that. So I couldn't do the range, but I could do the domain. You just put it all together and you say, well, there's all those restrictions. It can't you got to set this as one little equation, has to be greater than or equal to 0. And this part on the bottom, two different things can't be allowed. And you put it all on one big number line. Try it. Make one big number line and make a list for yourself of it can't be this and it can't be that and it has to be bigger than this. I'll give you a second to work. First part, you set x minus 5 needs to be greater than or equal to 0. So x needs to be greater than or equal to 5. So on my number line, I know 5 is important. Can it be 5? Yes, because it says we're equal to. And if you just think about it, if I stick in a 5, it does not cause it to crash. Yes, there's a 0 on top, but that's okay. Zeros on top are okay. It's just zeros on the bottom that are a problem. Okay, so the 5 works. And generally, we want to go bigger than the 5 is okay. But there's going to be a little problem incoming in a minute. Because down here, we got two things. X cannot be 4, and x cannot be negative 6. So I'm going to put on my number line 4 and negative 6. I have them in the right order now? Yes, I do. Okay, so now, if it can't be this, and it can't be that, and it should be bigger than 5, remember how we got that from this? It should be bigger than 5. Okay, now, is it okay in here? Yeah, it's okay in there. What if you weren't sure? Then put in 4.5, and you find out. Wait a minute, I was wrong. I'm glad I checked. Maybe that should be a lesson to you, that I even thought that I had it, but I should check. 4.5, watch what happens. Square root of 4.5 minus 5, do you get I'll have a negative underneath the square root? Ah, that's not allowed. Okay, so that doesn't work in there. How about in here? What's between negative 6 and 4? My favorite thing, 0. I'm going to test 0 really quick. I stick in a 0 and right away, 0 minus 5. I got a negative underneath the square root. I can't have that. Can't work in there, and I bet you it can't work at the end either, but I'm just going to check it quick. I'm going to put in like negative 8. If I put in negative 8 right here, negative 8 minus 5 is going to be a negative underneath the square root. Still can't do it. That's out. Final answer is from 5 to infinity, and yes, you'd usually write that like this. And can it be 5? Yeah. Okay, so key steps. When you see a problem like this, it's got a square root in it. Take that and take whatever's underneath it and set 2x minus 3 greater than or equal to 0. Solve it. Make a number line. If you ever have one that's got a denominator, make sure that that denominator can never be 0. Here's a weirder one. There. And you'd set things on the bottom. X cannot be 3. And what's this one? X cannot be 0. So then I'd make my number line. Notice I'm making number lines a lot. You will be too. Can't be this, can't be that. Can be everything else. This one, 2x greater than or equal to 3, x greater than or equal to 3 halves. Then I make a number line, as long as it's bigger than 1.5. Could be equal to 1.5 even. Final answer, 3 halves to infinity. All right, that's domains and ranges of functions. The ranges are going to be the easy kind. They'll be the kind you just graph and go, what's the range of that? And then you go, oh, I should graph it, because he said to graph the ranges. And just don't go brain dead and forget how to graph an equation. That's the y-intercept. That's the slope. Y-intercept, slope of 3. Remember that? Okay. Now what's the range of it? The range is how low to how high. Well, what's the lowest it'll be? Extend this puppy out. We'll go to negative infinity, right? What's the highest it'll go to? Infinity. So on the range ones, draw yourself a little picture. In the very beginning of the worksheet, it's going to be things like this. You're going to say, is that a function or not? How do you tell? Vertical line test. Would this pass the vertical line test? Therefore, it's a function. Okay. What if they don't give you the graph? What if they say y equals absolute value of x plus 3? Is that a function? Yeah, because if you graphed it, it'd be a v, and it would pass the vertical line test. Okay. All right, good enough. Here you go. And now, after I hand these back, I can get you your test back. Okay, I'm actually going to continue recording just as I get you started on the worksheet. So problem number 1. I always like to get you started because I feel like it goes so much easier once you're going. Y equals square root of x minus 4. So in your head, you got to kind of think of what that thing looks like. You remember what the square root looks like? Except this guy's been moved where? Right to the right or to the left? Right. So it looks kind of like that. Okay, maybe a little more curvy, but anyway. All right, so then, does it pass a vertical line test? Yeah, so it's a function. All I ask is it a function? All right. And you do the same idea for 2, 3, and 4, and you got to remember how to graph those things. Now, I want to warn you, number 3 is a little bit messed up. You see how number 3 says x equals blah, blah, blah? You probably don't know how to graph that, so you probably should solve it for y first, then graph it. All right. And 5, 6, 7, and 8 already have their graphs, so those are actually easier. When you get number 9, first one where they ask you for a domain, and it's kind of a weird one, so I want to help you with number 9. Everybody go to number 9 and take a look at this one. F of x equals x squared plus 4. And the domain of this thing. Remember how I was saying, watch out for square roots and watch out for denominators. What if it doesn't have a square root or denominator? Then you're good. And the other thing is just graph it. Remember how it looks? It's a parabola, so shifted up 4. It looks kind of like this. What's the domain of that? Domain means how far can you go this way, how far can you go that way? They can go forever, so it's all real numbers. If you wrote this, I would totally understand what you meant. Big R. That means all real numbers work. Or you could say negative infinity to positive infinity. Either one's okay. Okay, so what you have to watch out for is things like number 10, where it's got a denominator. And you got to say, well, all real numbers work except for 3. And you draw a little number line for it, and then you give a good answer. You need number lines. You have to have number lines as your work. Sometimes number 12 throws people off. It's nothing more complicated than this. What are the 2 things that won't work? What do you think on number 12? 0 and 3. So make a number line where 0 and 3 won't work, and then you're good. You're just asking yourself, everything works except what? You don't want 0 in the denominators. So some of them are all real numbers where you wouldn't think so. Like everything will work because you realize I can't make this thing have a 0 in the denominator. I can't stop it. All right. That's truly all I have.